Hello, how you doing, students? Welcome back. Glad to meet you again. This time with chapter 8, and this is the last chapter in Edexcel Mechanics 1. All right, and it's about moments, right? I think you have had moments on all level, and maybe the basics shouldn't be a problem for you. We're gonna start the part 1 of chapter 8 on moments. And before we officially start the chapter, I would like to chat with you a little bit about moment. What's moment to begin with? What is moment? Moment is the turning effect of a force times produced by the turning effect of, or let's say produced by a force. That would be better if we say it this way. The turning effect produced by a force. The turning effect produced by a force times the perpendicular distance between the force and the point about which rotation or turning takes place, or let's say occurs. Better say occurs. All right, let's take a look at the definition. It is the turning effect produced by a force times the perpendicular distance between the force and the point about which rotation occurs, which we call, this point is called what? The pivot. We call it usually what? The pivot. Which means, if you, for example, this is a door, this is the wall, and this is the door, and this is the handle of the door over here. If you are to open the door, you are going to apply a force. Say the door is going to open inwards. Now this is the axis around which rotation occurs. This is called axis of rotation. It's just like the pivot here. Axis of rotation. Because the door is going to rotate once you open it. Let me ask a question. Would it be easier to apply the force perpendicular to the door or at an angle? Of course, perpendicular. If you apply the force perpendicular to the door, you are going to produce more turning effect, which means more what? More moment. So, think of this as the pivot, and you're going to apply your force what? The farther away you move from the pivot, the easier you can turn the door, because you would produce more turning effect. So would it be easier to open the door at that point? Or that point, or that point? The farthest point, that's gonna make a larger distance from the pivot. This is the distance here. This is the distance, and this is of course your force, which is supposed to be what? Perpendicular to what? This is 90 degrees. Perpendicular to the door. So this is the force and that's the distance. Here the moment equals to force times distance. And the perpendicular force is the force that produces, so perpendicular to what? To the distance. Okay? The perpendicular force, so the force has to be what? The distance has to be perpendicular to the force, or the force has to be perpendicular to the distance. So this symbol here means perpendicular distance. Force times perpendicular distance will be moment, or what we call turning effect. The farther away we push the door, the more turning effect we produce. Now, what's the unit for moment? Speaking of unit of moment, unit of force is in Newton, and unit of distance is meter. So the unit of moment will be what? In Newton meters. Newton meters. Very good. Well, what do we got next? Okay, the moment of a force measures the turning effect of a force on a rigid body. It is the product of the magnitude of the force and the perpendicular distance, as we have pointed out, the perpendicular what distance. All right. So clockwise moment about F. Clockwise moment usually is. See moment, of course. Remember that moment is a vector quantity. So it has direction and magnitude. But because moment is rotation, the magnitude is not going to be in one direction. It will be what? Rotational. So it's going to be either clockwise or what? Or counterclockwise or anti-clockwise. Clockwise or anti-clockwise. Now here, I'm moving this object over here, and this is my pivot. This is P means the pivot. Okay? And this is the force. I'm applying the force here. Look, this is the force. And this is going to what? Turn. This thing is going to turn, right? Around the pivot. So it's going to turn like what? It's going to turn like this, right? Okay, so the force here is producing what? Clockwise moment. Producing clockwise moment. Again, I'm applying a force on this body over here. This is a rigid body, and I'm applying a force on it. So it's going to be turning this way around what? Around the pivot. This way around the pivot. So that is clockwise moment, because its direction will be in the direction of the clock, clockwise. That's a clockwise moment. And if I want to calculate, if I want to calculate the moment, since they are 90 degrees apart, or they are perpendicular, so I can just calculate the moment as moment equals whatever the force is, its magnitude in newtons, times what? The distance. Because now I shouldn't worry, because the distance between, this is the line of action of the force. Remember, this is the line of action of the force, and this is the distance, and they are perpendicular. So the moment will be force times what? The perpendicular distance, which is that distance over here. It's already perpendicular, as you guys see. Well, in other situation, you're going to see something like this. Look at that. Where is the perpendicular distance? That is the force, and this is the rigid body. This is the rigid body, and it's being acted upon by a force F. So it will be rotating what? Here is the rigid body, about B. This is the pivot. This is the pivot. It's going to be rotating around the pivot over here. This is the force, so it will be rotating like this, which is again what? Clockwise moment. This is a clockwise moment, all right? Now the distance between the line of action of the force and the pivot is going to be that distance over here. This is the distance. This is the distance. I'm going to call it what? X. X is what? Perpendicular distance. Perpendicular distance. All right. Well, first, where did I get d sine of theta? If you use right triangle trigonometry, then let's do sine of theta, because sine of theta will give you what? X. This is X. This is X over here. X over what? D. This is X. So we are calling this what? X over here. This one is X, all right? So we'll do sine of theta equals to, this is theta, opposite, which is what? X, over hypotenuse, which is D, right? So that means X, which is the perpendicular distance, equals to what? D sine of theta. D sine of theta. I'm going to have to use what? The perpendicular distance, d sine of theta in this case. Because the distance that produces the maximum moment is the perpendicular distance. The force that produces the maximum moment, or the maximum turning effect, will be a force that's perpendicular to what? A force that's perpendicular to the distance. All right? So I always take the distance perpendicular to the force. And I was able to calculate X, which is the perpendicular distance between the pivot and the line of action of the force. You're going to tell me that the force is acting over here. No, I'm concerned about the line of action of the force. So this is the line of the action of the force, and this is the distance over here, and they are what? Perpendicular. How am I going to get the value of x? I can use what? Right triangle trigonometry, as I have done. I think we need some practice on this. Well, here is some practice. Find the moment of each force about the point P. Point P is your pivot. That's the point around which rotation occurs. That's the point. So this is your pivot over here. This is the pivot, and you're going to calculate moment. Moment equals to force times distance. What's the force? Force times perpendicular distance. The distance is 3 meters. This one is 3 meters. So it's already perpendicular. I shouldn't worry about finding the perpendicular distance. So it's going to be what? 6 newtons. 6 newtons is going to be 6 newtons times what? 3 meters. So the answer is going to be 18 Newton meters. But over here, I need to calculate the perpendicular distance. This is the perpendicular distance. Remember that x is what? Perpendicular distance. This is the perpendicular distance x. And moment equals to what? Equals to force times perpendicular distance, which is x. Well, this is what? You can call this d. So now you can do sine of 30, sine of 35 equals to opposite, which is x, over what? Hypotenuse, which is what? 13. So x equals to what? 13 sine of 35. Now x equals to 13 times of 35 equals to approximately 7.5 meters. Now I can calculate the moment. Moment equals to force, which is 12 newtons, times the perpendicular distance, which is 7.5 meters. So the moment equals to 90 Newton meters. Perfect. Probably we need a little bit more practice on this. So let's do some more practice then. Look at that. This is my pivot over here. I got two forces acting, causing rotation about that pivot. This is the pivot over here, P. And there are two forces. The first force produces what? What does it produce? Clockwise moment. But the second force about P, because this is gonna what? It's gonna rotate around P this way. The second force do a rotation that's what? Anti-clockwise. So that's gonna be what? Anti-clockwise. This is anti-clockwise, produces anti-clockwise moment. So I'm gonna calculate the clockwise moment produced by the 5 newtons, and then the anti-clockwise moment produced by the 80 newtons, and then I'm gonna find what? And I'm gonna find the resultant moment, okay? So I'm gonna say now the first moment. Let's call this F1 and this F2. So let's calculate moment 1. So moment 1 equals to, it's what? It's a clockwise moment. Equals to what? The distance is already perpendicular to the line of action of the force. So equals to 5 newtons times what? 2 meters. So equals to what? 10 Newton meters. What's that? Clockwise. It's a vector. You have to indicate its direction. Now moment 2, which is the moment produced by force 2 about P, equals to moment 2 equals to, we need the perpendicular distance. So all you need to do is just use sine, because the perpendicular distance will be what? Would be that distance over here. That is the perpendicular distance, right? Correct? So you're going to have to find x. X is always what? Whatever this number is times x equals to what? 2 sine of what? Of 50. And I have taught you how we got that from right triangle trigonometry. So in this case, the moment is going to be force, which is 80 newtons, times what? 2 sine of 50. So the answer is 12 equals to 12.3 Newton meter, but this time it's what? Anti-clockwise, right? Anti-clockwise. So that means which one is bigger, the clockwise or the anti-clockwise? The anti-clockwise. So we're gonna write resultant moment equals to 12.3 minus 10. So that will be what? 2.3 Newton meters. And since this is bigger, so we're going to say what? Anti-clockwise. All right. There we go. Let's see what we got next. Now, the diagram shows a sign. This is a sign. It's just a sign hanging from a wooden beam. The sign has a mass of what? 4 kilograms. 4 kilograms, that means its weight is what? What's its weight? Because weight equals mg, as you know. So that's going to be 4g in newtons. That is the weight that the sign is exerting on the beam. And the beam, that's beam PQ. Okay, beam PQ. That is the beam PQ. All right? And the sign is exerting a force of 4g newtons. Calculate the moment of the weight about P. That means you're gonna take P as your what? You're gonna take P as your what? Your pivot. So for part A, I, moment equals to the sign. What force does it exert? Its weight, 4g. And what's the distance? It's going to be 8 meters. So it's going to be what? Force times distance. So that's going to be 4g times 8 meters. So the answer is going to be 32g in Newton meters. So 32g equals to 313.6 in Newton meters, right? In Newton meters. If you want to indicate the direction, it's going to be what? What is it? Clockwise, right? And for double I, we need the moment that the sign, the weight of the sign produces about point Q. About point Q. Well, if this is your pivot now, then the rotation about Q will be what? Anti-clockwise, isn't it? Right? So that's going to be moment equals to force times distance. The force is 4g, which is the weight of the sign. And the distance is, what's the distance? It's going to be 12 minus 8. This distance will be what? 4 meters. So times 4. And that's going to be what? 16g, which is 156.8 in Newton meter anti-clockwise. Because about the Q, the moment will be what? Look, what's that? That's anti-clockwise. The weight of the sign about P will be what? Clockwise. There you go. Part B of the same question. Comment on any modeling assumptions you have made. Well, I assumed that the beam has no weight. So I assume that the beam has no weight. Because if the beam has a weight, I would have taken that weight into what? Into consideration and used the weight of the beam, if there were to be. So I assume that the weight that the beam is light. Light means what? Weightless. That's the assumption I have made. All right? There we go. What do we got next? What are the conditions of equilibrium? Well, let me talk to you about the conditions of equilibrium. Let's say that we have a rod supported by 2 trestles or supports I'll just say just by 1, supported by 1. Now let's say that there is a particle over here, and that's particle P, and this is the weight of P. And we have a particle over here, and that particle is what? Q, and this is the weight of what? Q. And I'm going to think of this point, which is point A, as the pivot. A is my pivot. Right? And now, as you guys see, if I ask a question, how many forces, this is what, a rod. How many forces are acting on the rod? You guys tell me. How many forces are acting on the rod? Are you going to say 2 forces? No, there are 3 forces acting on the rod. Because if that support wasn't there, what would happen to the rod? It would just fall, right? So that means the support is exerting a force on the rod upward, right? That's a contact force. So there is a force by the pivot. You can call it force A if you want to, right? So there are 3 forces acting on the rod. Remember that any support is always supports that are underneath a rod or a beam or a plank always exert forces on the rod or the plank. Now, the rod, in order for the rod to be in equilibrium, which means balanced, there are 2 conditions that must be fulfilled. First, resultant force acting on the rod must be or must equal 0. Which means the upward forces must equal to the downward forces in this case. So the upward forces, which is FA, must equal to what? The downward forces, which is weight of Q plus weight of what? Of P. That's the first condition. The second condition, that if I call this distance 1, and this is distance 2, and as you know that the angle between the distance and the force is already what? Right angle, so it's perpendicular. So we don't have to worry about obtaining the perpendicular distance in this case. So, so notice that if this is the pivot, this is going to produce what? Anti-clockwise moment. And this is going to, about the pivot A, this is going to produce what? Clockwise what? Moment. So the second condition for the rod to be in equilibrium is upward forces must equal downward forces, which means the resultant force acting on the rod must be 0. Also, resultant moment acting on the rod must also equal 0. Which means clockwise moment must equal to what? Anti-clockwise what? Moment. Clockwise moments equals to anti-clockwise moment. So remember these 2 conditions at all times when you are solving moment problems. We're gonna be using these 2 conditions and benefit from them to solve problems. Remember that resultant force is 0 means upward forces equals to downward forces. And clockwise moment must equals to anti-clockwise moment. If these 2 conditions are fulfilled, then the rod would be in equilibrium. All right. We're going to do some practice. And in that practice, we are going to use these or benefit from these 2 conditions of equilibrium. These 2 conditions of equilibrium. All right, I think we're going to start doing some practice so we can apply these 2 conditions.